air conditioner for each room. Instead, it has one large air conditioner, which is part of a central air conditioning system. This is the outdoor unit where heat is released. Through the grill, you can see a large fan which blows air across the condenser coils. Inside the building, in this unit, are the cooling coils. A fan circulates air from the cooling coils up through the metal ductwork to the various rooms. In each room, there are two sets of vents. Near the floor are vents through which the cool air is blown into the room. As the cool air absorbs heat from the room, it becomes lighter and rises toward the ceiling. Having absorbed heat from the room, the air reaches another set of vents, where the air is drawn out of the room to be cooled once again. This animated drawing shows how the air circulates through the room. We call this process convection. Convection currents like these are also found in a room having an individual air conditioner. This is how warm air is brought to the air conditioner to be cooled and recirculated.
All right, everyone. Thank you for joining us once again on Did You Know, the ESCO HVAC show. We're so grateful that you're hanging out with us today. We're going to be spending some time with David Richardson from National Comfort Institute. How you doing, sir?
Hey, I'm great. Thanks for having me on, guys.
You know, it's a pleasure for us to be able to spend time with other industry educators, especially those that are really focusing on the transitions that we're seeing in the industry and the higher demand for performance installations for performance equipment. That's really what it comes down to, right?
It does.
So we want everyone to hang in with us, ask questions along the way. We want to know where you're joining in from. I'm just outside of Indianapolis in Brownsburg, Indiana. David, where are you joining from?
Right outside of Frankfort, Kentucky, a little town called Lawrenceburg, central part of the state.
Not too far. It's a couple hours. It's probably 2 hours or so from here, something like that. And Ty?
San Angelo, Texas.
Absolutely. All right, so let's talk about a little bit of the evolution in our industry. You know, that little video kind of sets the stage for where we've been for a long time. And we keep saying we've spent about 50 years doing the same thing in our industry because the equipment hadn't really changed very much. But unfortunately, along that way, we lost some of our professionalism in understanding the things that we're installing and working on. And so as an industry, we're trying to elevate that. So we have a lot of educators going, I would like to learn better practices, but I wasn't really taught in the industry too many of them. I'm starting to learn them now, but I need my resources and I need to learn what I should be doing. And so I'd love for you to share with us, David, a little bit about how you ended up with NCI, the history of NCI, and why it's made an importance for you, not just as a contractor, but as an educator.
Well, and you mentioned where we lost our way. I love that because the video that you started off with, when you look at, the craftsmanship that was involved in that system that went in, I'm assuming 50s, 60s, there was a level of pride in the work that was done. And one of the things that the two founders of National Comfort Institute, Rob Falk and Dominic Garino, saw was that we had lost our way. And it started back in about the late 1970s, early 80s, when the focus went off of the craftsmanship that the contractor provided, and it started going strictly to the box. And what happens, our focus switched. As an industry, we switched from focusing on the system, which is built by contractors, professional contractors, and we started focusing on the equipment. Well, when that happened, we became equipment repair people and salespeople, and we took our focus off of what our core product was. We lost sight of what was important to our industry, which is comfort in the people that we serve. So Rob and Dom wanted to get back to that. They noticed there's a lot of HVAC systems that don't work. So they started back in about 1993. And in the mid 90s, I had read articles by Rob Falk for, a long time, and had seen things about static pressure and airflow, and thought, this is neat, air balancing, but never really connected what it could do until I saw an article in Contracting Business. I think it was back in 2000 about how all this stuff was tied in to fix a comfort problem that 3 other contractors had been in, and all they wanted to do was replace the equipment. So they kind of think this goes to the focus. Well, about this time, I had 1 foot out the door of the industry, working for a family company, and because I didn't see any future in HVAC at this point.
Right.
And I thought, if we're going to have to continually worry about getting sold out on a job by $50 to $100, knowing that we did better work, we didn't have a way to prove it. So I was thinking, I'm young enough, I can get out of the industry, go back to school, get a degree, whatever. And it was about that time that I actually met Rob Falk. My dad was real good friends with one of the gentlemen that used to put on in Kentucky what was called the Energy Management Conference.
Sure.
And he invited Rob to teach. So I got to meet Rob and saw the missing pieces that we had. Got into a class and found that this stuff made HVAC fun again. We started solving problems that people said were unsolvable. And I firmly believe that what they taught us saved our family company. We went from the red and me leaving to being very profitable and solving problems that no one else could solve. And that's one of the reasons why I'm so passionate about what we do at NCI, because I know how much it changed me. It went from turning me from someone who was an equipment repair person to someone who went back to being a true troubleshooter and a craftsman and being able to prove it through measurements and help customers understand the state of their systems.
We always talk about how data is the driving force for all analytics, and especially in our industry. And as we start talking about these new generations of equipment, these new demands for higher efficiency installations, and to make sure that the systems are performing, like when we look at this chart, a lot of people don't understand how much the HVAC industry impacts energy usage, right? As we start moving forward, we're going to have a much larger conversation on reducing our global footprint by reducing our energy consumption, using our resources more efficiently. And when you start looking at how much energy is being utilized by space heating, space cooling, water heating, and ventilation and refrigeration, it doesn't leave a whole lot else in there, right? So that is the reason that we have like the U.S. Department of Energy and the Environmental Protection Agency making changes, making advancements for the industry as a whole that is actually going to be encouraging people to be more proficient at the things they do. And so some of our practices that we got away from, like understanding the envelope and understanding the ductwork and the airflow required for the system to run properly, are going to be more important going forward than they probably ever have in the past. And so I always like to make sure people understand what we're talking about when we start looking at these kind of numbers, that those are a lot of changes that we have to prepare for as an industry.
Yeah, and the results are there. They have been for a couple of decades. What we found, we did 2 studies, and a third one's kind of getting wrapped up. And what we found was the average HVAC system only delivers 57% of its rated capacity into the living space, and that's on an average. Some systems are a little better, some are a little bit worse, and those can be improved through measurements. They can guide you to surgical repairs that can be made to a system that can increase that delivered efficiency to over 90%. And a lot of guys wonder, where does that 57% come from? Because I used to assume, and I'm sure many other people do, is that let's say that you take a 95% efficient furnace and a 22 SEER air conditioner, you put those on an existing duct system, you kind of assume they operate at that efficiency, and it couldn't be farther from the truth. What we found is the installation determines the efficiency, the operating efficiency of that equipment, more than the equipment itself does. So the installation conditions, getting back to that craftsmanship, is what delivers the efficiency to that customer. And so, when you put a fantastic piece of equipment on a substandard duct system that someone was driven by low price to install, that poor homeowner's nowhere getting what they've paid for.
No, absolutely. When we start talking about that whole commissioning and understanding, we're going to be doing a lot of education over this next year on proper installation and commissioning as well. We've actually always been required to do a commissioning report for our installation. I always tell people, if you don't believe me, go to the last page of your installation manual, and you'll actually find what you should have been doing on the first page of the installation manual. So if you
Is
open up the last page, you'll typically see a uncompleted and unfilled out commissioning report.
is that in that knee pad package?
That is in that knee pad. It absolutely is. And it's probably the one that's collecting the most dirt and oil and water. So you never actually open it because it's stuck to the rest of them. But it's something we should have been doing the whole time. So as we start getting into some of these more advanced pieces of machinery, it is so critical, especially when we talk about things like airflow, right? So here's an example of some equipment. This is actually from, I think this wasn't the that might have been over the 449. It was one of the facilities that we've visited here recently. When we start talking about inverter installations and we start talking about the changes of motors, if you haven't realized, we've already moved away from PSC motors into ECM motors for majority of our indoor units, right? So we've replaced them with higher efficiency motors. I cannot get the performance out of a inverter in particularly if I have not started with proper airflow. One of the things that I would find, yeah, it's people don't think about that. They think, oh, it's an inverter. It's actually it's going to compensate, its capacity, and it's a variable speed blower, and it's actually going to compensate for this poor static pressure. And that is absolutely not the case. When we start thinking about capacity, most of our systems are designed around a external static pressure. Typically, it's going to be in that 0.5 inch or so. It depends on the manufacturer. But what we don't think about is what happens once that static pressure starts changing, right? If my static pressure starts increasing on a variable speed blower, I'm actually going to potentially start locking that thing out. Once we start getting above 0.8, that motor is going to start protecting itself from that excess heat that is drawing. And here's the thing that many contractors forget about when we start talking about variable capacity systems. Okay, so David, let's assume that I've got a newly installed inverter-driven system, and I haven't paid as much attention to airflow as I should. And so I've got poor airflow across the evaporator. That outdoor unit is, what is a primary driving force for an inverter from that outdoor unit? Think about like superheat, right? So a lot of our units are being driven by superheat and compressor discharge temperature. Well, if I start reducing the airflow across my indoor unit because of my excess static pressure, it changes my superheat, which is going to change the modulation of my outdoor unit. It's actually going to affect my capacity in correlation with airflow. And so never in our industry have we ever been to the point where we have to focus on airflow for maximum efficiency and capacity of our outdoor units. And I know I went down my tangent, but I absolutely love getting on that topic. And there's so many people joining in here. This might have actually been from the 412. Yeah, it was. Okay. So that was the second Daikin facility that was installed. And we've got Garrett joining in out there. Garrett Middleton, thanks for hopping in here. Mr. Tebby down in Louisiana. Mr. Silberstein, if you got any comments, or you want to hop in here with us, just let us know. We'd love to have you. All right, sorry, I'll get off from that tangent.
I love it.
It's one of my favorites.
One of the things I hear from people all the time is saying, well, they just don't build equipment like they used to. And I said, well, maybe not. Are you installing it, checking the airflow, checking these other things? They said, well, oh no, we don't have time for that. I said, well, you cannot blame the equipment if you're cutting corners yourself. I said, you first have to control what you can control. I said, if you're not installing it right, we cannot blame the equipment. So we have to first do that first step of doing it right, doing it how it's supposed to be, fixing the airflow. And if we do everything right, then we can start looking at the other side, but not pulling proper vacuums, high static pressures, not being able to move enough air, leaking ductworks. I mean, it's like having a hot rod engine and, putting in the wrong transmission, rear end, and tires. It's not going to get us where we need to go.
That's a great point.
Yeah, people, I know we hear it all the time. People say, they don't make them like they used to. And they don't. They make them much more precise. Our tolerances now, I mean, and this is the same thing can apply to automotive. The tolerances are so much tighter. There's a precision now in how the equipment is being manufactured that if we continue to try to use methods that we used 40, 50 years ago, we're not going to get the same results because you have to be precise. And this is one of the reasons I love seeing the implementation of so many digital test instruments, because there's a level of accuracy that we can get to that's needed for precision equipment that we didn't have, just even 20 years ago.
That's probably a topic we can hang around here for a minute, because a lot of people are starting to look for these resources. And I think I've got in this section of it some things for us, just some talking points, right?
Yeah.
Some talking points about professional measurement. And this one's actually borrowed right out of our Daikin installation manual. So let's just talk like as we start looking at our professional technician, right?
Mhm.
Building that professional technician. We don't have to get too deep into the specifics of the programs, but let's help our educators. We got educators out here today that are looking for, how do I improve my program? How do I start looking at these high performance measurements? And what am I actually looking for? Like, what are these test and tool instruments that we're talking about?
I love Ty's ready.
All right, here we go. So basic fundamentals, when we start talking about measuring static pressures, we've been measuring static pressures for, almost 100 years in water column forms, right?
Yep.
We've used the magna helix. Ty's got one right there. That was the practices that we used. I've even seen some of those original ducted systems that had magna helix installed in the ductwork, especially on
Yes.
zone systems, right? And so when we start talking about professional measurements, of course, we've seen digital technology, like using digital manometers. But let's go a little further and talk to people about ways that we can even get better, accurate measurements of our airflows.
It's a lot of this ties down. One of the most common issues that I see is testing in the wrong locations.
Hmm.
And one of the things that we teach at NCI, it's what's called the path to performance. And PATH is actually an acronym that stands for the foundational measurements that we take. The P stands for pressure, which you
Mhm.
could put static pressure or refrigerant pressures in there. The A stands for airflow, the T for temperature, and the H is for heat or BTUs, which is the product once you have airflow and
Yep.
temperature or enthalpy change. And we see measurements taken in different locations, taken out of context. Something that Ty pointed out, I guess Ty was probably about a year ago, was that many professionals were using static pressure as a silver bullet, and they were taking it out of context, and they were trying to make it mean more than what it really did. And so I think one of the things we have to keep in mind is every measurement that we take should have a purpose, and we need to be looking for an intended outcome from that to help us troubleshoot a system and then understand how to explain it in terms that an average homeowner can understand. And as we're looking at being professionals, we can go down rabbit trails of talking about very technical topics, and then no one understands the words that are coming out of our mouths. So I think we have to be very careful on the translation of that as well as we talk to people, especially with the investments that they're making with some of this equipment. So as educators, I think one of the things is trying to take, if you could think of this as a scale of like A to Z,
Okay.
is many times as we learn, as we get educators, we become guilty of what's called the curse of knowledge and experience.
Hmm.
We forget where we came from,
You betcha.
and we'll explain things super technical. And guys are going, they're new, they're at the A level, and they're coming in and they're like, I don't understand this. And if we talk over them and we don't break it down into very core principles that they can understand, they're going to be lost. So we do have a responsibility to be guides and make it as simple as we can. And Clifton, you had an example earlier I loved because it was so visual and simple. We have to get down to those levels of simplicity and understanding.
Yeah. And for those that don't know what we're talking about, you're going to have to wait. We might be doing some balloon chemistry from the local Cliffy the Clown, but you got to wait for that episode. That's to come. Yeah. And that is exactly what we're talking about here, Eugene, is too many times we're not evaluating the system before and after. And so I would like for us to discuss a little bit about some of the ways we can test these systems before and after. And I know it's not always possible, but with a lot of today's technology, we can actually do measurements and calculations before we do that swap out, especially with things like the true flow grid that a lot of people haven't even been introduced to yet. And I think we're going to have TEC in here to do a really deep dive into the true flow grid. Like Ty's got one right here. So can you
I
explain?
love this thing.
And
I absolutely love it. I have a whole bunch of tools for measuring airflow
Mhm.
because once I found out, somebody told me once, if you are not testing, you're just guessing. And I thought I was a bad, but just for being like doing some great ductwork. I thought my ductwork was better than most people around me, but it still wasn't right because I wasn't testing it. It was better, but it still wasn't right. So it was like less wrong. And when I started testing and testing properly, I got to see that, man, if I actually do these calculations, I can have proper performing systems. And then I found out I could use smaller systems and have happier customers with lower humidity and proper testing. For example, I don't know how many of the people out there remember one of these. Um, when I was working for a company, we did every single house that we would test this before and after. But the problem was, if you're only looking at one number, they would
Right.
hold it a certain way, and they would write down the numbers, and then after we held it a different way to show that it was working better. And so the problem with some of these analog tools, although we can get the numbers, it's not as accurate. And doing something like the True Flow Grid, it has an app that goes through and it has a small manometer that's very, very, very precise. And we can walk through. It says, do this step here, get these numbers. What do you get? And then it does these calculations for us. And it leads us, whether you're an experienced tech that's been doing it for 50 years or you're new to it, it leads you through these steps and very accurately gets those readings. So whether it's a new person doing it, a salesperson doing it, somebody with 50 years experience, it gets you these numbers, and then these numbers can be then shared with the homeowner. Hey, here's how your system's performing right now. And it can even do a lot more, where it gives you steps of saying where your airflow problems are, where to look for these airflow situations. And what's cool is NCI has been working with the True Flow Grid and also MeasureQuick to do these workflows to tie this in. So we're looking at the bigger picture. So we don't get that appliance fixation. We're looking at that bigger picture. And so, man, once you use this, you won't want to use anything else. So I started using this when I was in Minneapolis. I started using it also. I was working with Craig Michelaccio, and I've been hooked on it. And it's expensive. Like, I'm not going to sugarcoat it. It's going to cost you money, but it's worth every penny of it. And once you use it, man, you won't want to use anything else because it just simplifies that process so much. And like I said, it hurt when I bought it, but it's worth it. It's absolutely worth it.
Well,
It's
a
an
tool.
investment.
It is.
It is an investment. And when you look at the testing aspect of it, one of the things that we promote in our training is we want to make sure that no contractor ever goes out and inherits a bad duct system. And because once you take a brand new piece of equipment and you install it on that existing duct system, you own it whether you installed it or not.
Very true.
And by testing, you're able to make a homeowner aware, or building owner, if you're testing on a commercial system, aware of the conditions that are there. And that way you can't say you didn't know. And one of the things that we're big promoters of is treating calls, service calls, maintenance calls, sales calls, just like you would if you were a medical professional. You think about any time you go in for a physical, or if you go in, even it could be for a broken finger. If you go in, the first thing they're going to do is make sure that you can pay. The next thing that they're going to do is they're going to take some very base tests. They're going to do a baseline, and they're going to measure your blood pressure, your pulse, your temperature, and your weight. And they're going to do that to gauge what your baseline is of your overall health. HVAC systems should be the same way. When we go in, there's HVAC equivalents of those vital signs.
Mhm.
Blood pressure, of course, is going to be static pressure. That's the system blood pressure of the ducts and all the air components that are going with it. It's kind of an indicator of overall health of the air side of the system. Pulse is, of course, going to be the electrical. Many times you see, and we're talking about the inverter and variable capacity equipment having surge protection. So making sure that the voltage is right there. Temperature, of course, is going to be a direct correlation. It's temperature. And weight, of course, is air. If you start looking at some of the bases of air, we've broken it into CFM, a volumetric measurement, to make it easier to understand. But really, it's measured in pounds per hour if you break it down into its core measurement. So we're dealing with weight of air and how it transfers heat and BTUs. There's ranges for all these measurements that we have in our industry, just as medical professionals do. And if they're outside of those ranges, then that's an indicator that there needs to be more testing. And that lets us know, hey, does this system, is it going to work, or is it not going to work? Or, kind of gives us an idea if we need to do more advanced testing.
Yeah, for sure. And I'm so glad to see Tony Gonzalez from Fieldpiece join out there. We've got a variety of Fieldpiece demos within this training course. So I'm not going to release this content yet. We'll actually talk about it. But in some of our training, we actually try to show people how to properly measure static pressures. And so if you haven't seen any of Fieldpiece's external static pressure measurement short videos. Tony does a fantastic job of introducing those just to help show you some of the good guide points and settings to use and what we're actually looking for. So we're grateful for our tool manufacturers to join us as well. And so you'd mentioned the whole pressure side of things, and I had a couple of slides that were sent over to me from TEC that I love to be able to share, because a lot of people don't understand what we're talking about, right? We can take numbers, but what happens when you calculate those numbers and you start getting a comparison towards
Right.
other systems? That's when we really start knowing. Because what if I grab all these numbers and I don't understand exactly what they mean? I know they're numbers, and I know that they're, they're maybe they're in the naughty zone, but I don't exactly know what happens when they're in the naughty zone, because maybe some of my other numbers look okay. Maybe my temperature rise is okay, but my static pressure is out. But what does it actually mean when I start putting them all together? Right? Because it could have been a gas pressure scenario that may not have been tested properly that was causing a temperature rise to look fine, but yet our static pressure off. So what we're starting to see is the use of technology to bring in a broader perspective and actually start comparing them to other systems so we can analyze that. So either one of you, I have not used this piece of the software. And I got to get me one. So can you explain a little bit what we're doing when we were talking about taking these blood pressure measurements and having them understandable?
Yeah.
Well,
Ty, you want to? You've already talked about the true flow.
I'll start it off, but one thing that's great about how it does this with the gauge, where you have the yellow, red, and green, the customer doesn't have to understand see a film or the weight, like all the stuff. They can look at it and see here's data, not just me writing something down and it's in the red or it's in the yellow, and they get to see, hey, there's an issue with that. So that makes it simpler. Measure Quick as well. It has the gauges. And for me, I can leave that to the customer. They don't know what all those numbers mean, but they see everything's in the green. They're like, hey, good. And they see things in the yellow and red, like, wait a minute, why is that in the red? And I know that same thing happened. There was a realization for me when I went to have my front end aligned on the vehicle. And the guy was talking about toe in and camber, like all this stuff. I'm like, I don't know what you're talking about. And he prints out the chart and it just has everything's in the green except for this one in the yellow. And I pointed to that one. He goes, that's what I was telling you with the toe in. I'm like, okay, it's in the yellow. I know that's bad. Like, there we go. So the same thing we're dealing with the customer. So having these things like this, where it's showing the red, green, the dials, it simplifies that so you can communicate this technical information to the customer very easily.
Yeah, what I like too is the validity of it, because many times customers are like, well, wait a minute, no one's ever said anything about this before. Now you're getting this from a third-party application. So there's validity in that. What's also nice is it breaks it down by components. One of the, a lot of guys, they'll go out and they can test and they're like, okay, we know this is wrong. But then when we have to progress to creating a scope of work to how do we actually fix this, it just goes off the rails. And a lot of times there's almost a panic and an anxiety that sets in, and we'll start throwing stuff at the wall and we'll say, well, we'll guess this will fix it, or we'll guess this will fix it, instead of being able to confidently say, I know that our return ducts, for instance, the pressure, our reading is in the red. So we can say, we know we need to focus our attention on the returns or wherever those bad measurements at. So it helps to guide you as you're developing a scope of work, instead of guessing, or even worse, saying, well, we got to rip it all out and start over from scratch. So it's a very surgical approach that's very detailed.
And sometimes our experience can lie to us. I remember I used to build really deep drain traps, and I was like, yeah, once you do this, we're not going to have the drain issues when it shuts off. And I was like, yeah, I got this figured out. I make the best drain traps. But I was completely missing the bigger picture of it's not a drain problem. It was an airflow problem. And the system was trying to tell me that. It was sucking all the air through that drain line, through that trap. And I needed to say, hey, I can fix temporarily this symptom, but we have the bigger problem is the airflow. And so when you start looking at everything as a system, and the house being the biggest duct of the whole house is the house itself, it changes how you look at the system. And then we start looking at how we can solve that customer's problem, looking at temperature and humidity and how that air is moving from one room to the next, how it's getting back to that system. It all ties together. And once you start seeing this, it's like the movie Matrix, when Neil saw the numbers on the walls, and once he saw the numbers, he can manipulate it. And for me, once I started seeing the numbers of airflow and measuring it and seeing the house and how house pressurization worked, it was like seeing the numbers. And once I saw the numbers, I could flex. I could fix that. I could change that. And it felt, really awesome. And now it's even easier than before because I used to have to write everything down and I struggle with numbers. I get numbers mixed up and I have to double and triple check things. And now with things like apps, it takes all that and it streamlines it so I don't make a mistake. Or if I do, it's giving me a notification that this is wrong. I need to do it again so I can go back. And then it makes it to where whether I'm doing it or somebody else do it, it's the same data, same information, and it's younger generations. People love the technology already. Customers like having that a formal report, just like the auto mechanics are doing now with the, hey, here's a diagnostic, we're red and green and yellow. Man, it's just, you can't beat that. I mean, it's just, it's embrace that. It's awesome technology that we have at our fingertips.
And one thing about the measurements, once you see them, once you learn how to do this, you can never unsee it. It's you can't go backwards once you see this. And all the educators out there, Ty, you mentioned, about the building connection. You're doing your students a disservice if you don't at least make them aware of how that affects the relationship of an HVAC system. I know when I went through trade school, we had to look at we had to do a manual J. And I'm like, this has nothing to do with HVAC. What does this have to do with, changing out a compressor, ohming out, relays? What does it have to do with it? And I was 100% right. It has nothing to do with HVAC, but it has everything to do with HVAC because it's the load that we have to condition. And when we started learning how that affected not only the performance of the equipment, but the comfort of the occupants, indoor air quality, things along those lines, we were disconnected from the part of the HVAC system that we so often assume. Whenever a customer has a comfort problem, they have an indoor air quality issue, such as dust, whenever they have something like uncontrollable humidity, they will never say, I'm uncomfortable, I'm going to call the insulation guy. That's right. Not once. They will always call us. So letting your students understand how these interactions take place. One of the things that helped our guys understand the influence of doors was comparing them to volume dampers. We started calling doors conditioned space manual dampers because they control air movement in and out. And when that's like a light bulb moment. And when you look, Ty mentioned the building being a part of the duct system. I mean, you think about it, you look at any HVAC system, the video that you showed earlier, Clifton, the building is what connects the air that comes out of the supply registers back to the return grills. And it functions off of the same similar principles of a traditional HVAC system. The ducts, they need to be airtight, they need to be sealed, and they need to be continuous. And they should have dampers. That's the same thing that can be said for a building. It should be airtight. It should be insulated as tight as you can. And you should be able to control the air in and out of it. But, when you start looking at comfort problems, you have to figure out which duct is really causing the problem. Is it the HVAC side? Is it the building? Or is it a combination of both?
So when I think about if technology, we could spend all the technology we have to build, if we're into boats, the best bilge pump that there ever was invented. We could make it use the least amount of electricity and move the most amount of water. But at some point, we should step back and think, maybe we should fix the holes in the boat.
That's a great one. So I'm going to play devil's advocate and look at it from another perspective here. Right. So we know as educators that we should be teaching these principles. And we are hoping that you're here joining us to learn how to implement these into your classroom more effectively and more efficiently. And I want to step back as a homeowner and show you an opportunity to prepare your students, prepare your technicians for encounters with homeowners that could make the entire scenario make sense. Right. So I'm going to say I have a friend. Okay. And this friend happened to have bought a brand new home. And the first winter that this friend was in this home, they had an 8-degree temperature rise between the first floor and the second floor. And then winter came around and they had an 8-degree temperature difference between first floor and second floor. And 18 service calls later, the friend was talking to the contractor that did the original installation, asking if they'd found anything. They'd moved ducts multiple times, installed new ducts, trying to come up with a solution. And the friend asked the contractor, hey, I've heard there's this thing called external static pressure that affects airflow of a home. And have you by chance checked that, or do you know anything about that? And the contractor says, oh, absolutely. It's great. It's a half of an inch. It's right where it's supposed to be. And the homeowner, my friend, says, oh, that's okay. Do you have anything that can show that can prove that? And the contractor says, no, I'm sorry. I was up in the attic when I was taking those measurements, and I don't have any proof of that, but that's what it was. So think about that. If you're that homeowner, you're that consumer that is just wanting some resolution, and the contractor coming to you does not even know how to take the measurements properly, doesn't know what the measurements mean, and doesn't know how to solve the problem. Those 18 calls that never truly resolved the problem could have been solved in a shorter period of time, understanding how those measurements actually play into all of this.
In less than 15 minutes.
There's the key. I was getting ready to ask that. Boy, you're already way ahead of me. So let's think about all of these measurements, right? So we talk about taking measurements like external static pressure. We talk about taking measurements for temperature differentials. And now we can talk about actually measuring airflow. Tony Gonzalez, like I said, who was on here a while ago, him and I had this conversation one time where we were talking about calculating capacity of a system, calculating the coefficient of performance of a system. How can you do that with modern tools when we're looking at instrumentation? And one of the problems that we encountered was accurate airflow measurement, because in the past we've always relied on manual calculations, using a blower data sheet and taking static pressures and looking at what we approximately are moving for airflow. Well, everything changes when we can actually bring in accurate airflow measurements. And so I would move this as a challenge to every educator. If you're not yet comfortable, if you're not yet exposed to things like accurate airflow measurements, like things with the TrueFlow grid, I think you should give it a try. I think you should experiment with it, and you'll see how much it can change the efficiency of your program. So think about this. I mean, tell me a little bit more about this 15-minute calculation, because I know how much time it takes for me to do an approximate airflow calculation.
A lot of this is once again going to depend on the role. And if you're a technician, there may be many technicians that aren't going to have access to a TrueFlow grid, so they may have to rely on fan tables. So they'll have to keep them in context. One of the most valuable things I have seen that on the old PSC blowers that fan tables showed was the relationship to external static pressure and airflow. And when a tech sees, oh, wait a minute, as external static pressure goes up, airflow goes way down. And there's usually an airflow cliff on those blowers. And, many people have seen The Price is Right, where, people are guessing there's the yodeler. He's going up the cliff. And if you don't guess, he just dives off.
He just dies.
The same thing can be said with a fan curve.
That's right.
As that external static pressure goes up, you're approaching that cliff, and it eventually just dives off, and fan performance just goes south. If it's on a ECM, you can also look at the watt draw, how much power that's consuming, and watch what happens as the external static pressure goes up. You start to see that the motors sometimes are consuming 4 to 5 times the amount of watts that they're rated for, and that is creating all kind of internal heat, and they just burn up. I mean, the motors are very tough. They're ball bearing motors.
Absolutely.
But they cannot handle all of that internal heat. So it cooks them, basically.
Exactly.
But going to the 15 minutes, it goes back to the medical professional that we went to. One of the things our industry has a problem with is we tend to get lost in the measurements. Something that everyone on this that's listening should remember is just because you can measure something, it doesn't mean that you should. Let me say that again. Just because you can measure something, it doesn't mean that you should. Every measurement should have a purpose. Think about this. If you've got a flat tire, you're driving down the road, your tire goes flat, you pull over. You're not going to start checking your oil level and your fuel level. It's totally disconnected, right? You're going to go straight to checking tire pressure. You're going to take the measurement in context with the problem that you're having. So as we go back to the medical to technician example, when you start off with these problems that you have to look for red flags, things that are going on. You mentioned if you changed an expansion valve 3 times in a row, there's probably a red flag there that there's something else going on. It happens. And I paid guys to do it, unfortunately. Yeah. So the measurements need to be focused on the problem that we're having. And if you're getting any type of issues like the expansion valves, compressors that are going bad, low superheat, limit issues, the motors are failing on, tripping out, fan failure errors on variable capacity. These are red flags that you need to go in and measure the blood pressure of that system. But, it doesn't mean that you go in and say, do a full, blower door test or whatever, because it has to be in context with why you're there. So start with the basics. Start with why you're there. We're big fans of measuring duct pressures before you start gauging up and seeing what's going on the refrigerant side, because the air is going to affect whether the charge is correct or not.
Charge always.
I mean, how many of us have done this before we knew any better? We used to go and grab the magic green jug and we would jack the juice to it until we could get the pressure up above where it wouldn't freeze and call it good. Never looked at the 40 degrees of subcooling that we had.
They don't talk about.
We were just trying to keep it from freezing because we didn't know any better. It wasn't any type of a malicious action. It's just we were doing the best we could with what we had.
Absolutely.
So 15 minutes, you can measure external static pressure. You can measure pressure drops across each of the components to see where the highest area of resistance is. You can measure your delta T. You can plot airflow on a fan table, and you can tell a whole lot about that system that is completely overlooked in 18 service calls of guessing.
Wow.
We just recently doing tech support, there was a group, and the guy was saying that he had a bad TXV, and I kept saying, hey, it's not the TXV, you have an airflow issue. And there was 35 people in there saying, oh, it's definitely a TXV. And I was the only person out of everybody saying, no, you have an airflow issue. So the guy replaces the TXV, does all of the other work, pulls down a deep vacuum, like he cares, he takes pride in what he's doing. And he comes back, it's like, guys, it's still, this new one's bad. I'm like, no, please look at airflow. So eventually he finally, out of desperation, starts looking for airflow, and he pulls the blower. I said, just pull the blower and look up in there. He pulls the blower and the secondary heat exchanger is completely clogged up. And he's like, oh, well, there's my problem. It was airflow. And I'm like, yes. But just with a simple 15-minute test could have saved hours and hours of work and unnecessarily parts and time you could be spending on other service calls just doing these 15-minute tests.
Yes. And that, that's also a challenge, Ty, that we find many times is that we start talking about all this stuff that you can do. Many technicians, if they don't understand why they're doing what they're doing, they hear two words. And if they hear this, they're going to revolt. And that's more work. And that's what my guys heard, because when I came back from conferences, I was all jacked up on Mountain Dew, ready to do all this new stuff. And they're like, oh, great, here we go again. This will wear off. And we had a hard time implementing because guys heard those two words. They heard more work. So as we went in and we continued to dig deeper, I started, saying, we just had a meeting. I was like, hey, help me understand why we can't get this down. This is important. And so the example that we used was an external evaporator coil. I was like, how long does it take you to take the door off of an evaporator coil, remove the delta plate, do a visual inspection? So they started going through all the examples. They're like, if it's a 90% furnace, this, and this. And, we get into like, it could take easily 15 minutes. I said, how long would it take you if you installed a port below the coil and above the coil, and you took two pressure readings? And I could probably do that in a couple of minutes.
Mm-hmm.
And I was like, if your measurement is above X number, the coil needs a visual inspection. If it's not, you're probably good. And they're like, we could tell it with that? I was like, yes. I was like, this isn't more work. This is work easier, work smarter. And guess what started happening after that? After they understood why we were doing what we were doing, we started getting a whole lot more measurements.
When you're talking about how fast those measurements are, I know, Ty, you've probably seen this screen by taking some of the measurements. Let's talk about that, because you were mentioning, above this point, you should be looking for a visual inspection. Is that kind of what we're talking about when we start looking at some of our dials?
Oh, I thought this is a Ty question.
Oh,
yeah.
Sorry. Yes.
Or either one of you. I just know Ty's used it and is very comfortable with using the software. And let's talk about some of the things that you have found by taking these actual measurements.
So it's got so many different options. One is it just will give you a CFM number, which is super easy and simple to do.
Right.
But if you put a few more probes in there in different places, it's able to then evaluate where your restriction is or where your most likely problem is. So now by putting it in this red and green, it's telling you, hey, you most likely have an issue in that evaporator coil. So now let's spend the time investigating that, or maybe across your heat exchanger so you can start looking at secondary, or your return is too small. So we got to solve that problem before we go anywhere else. And it's in the numbers, because we can have a customer that has 5 or 6 times they've been to the house and the return air is too small. And I was like, well, it's always been that way. Well, now you have something else backing you up saying, hey, nope,
Validation.
the numbers also say, and the little red and green dial also says, hey, this is where we have a problem at. So it does simplify that. It makes things easier. It makes that conversation with the customer easier and faster. It makes your job a whole lot easier and faster, and it makes that system work better. And once you start doing this, everybody wins.
Yeah. And that's, that's another fear that many people have is if they have overlooked this for years, how do they talk to a customer about that? When that customer says, oh, wait a minute, you've been here, Clifton, to your point, you've been here 18 times. You be honest and you tell people that you're learning a better way and you're learning about something that less than 5% of the industry understands. Air is what we do as a business. And many times it's one of the least understood aspects of what we do. And you're trying to get better. That's what you're doing. You be honest. And if you put a system in on a bad duct system and somebody says, well, you should fix it for free. No, you shouldn't. Never apologize for the results. Think about a doctor. If I go to the doctor and I'm running high blood pressure and I'm overweight, he's not going to apologize for those conditions. The doctor will say, I'm sorry you're fat and don't eat well. He's not going to say that. He's going to focus on the solution. Here's what we need to do to get you back to where you are, where you should be. And guys, that's how you should handle it. If you're talking to a customer, be honest, be upfront, and let the measurements talk. It's your job to be an interpreter. It's your customer's job to decide whether they're going to let you do the work or not.
And this is where NCI really shines because there's so much stuff that we can do. Like this trade is very technical. There's lots of stuff to do. And then once you start testing and you get the information, how do you present that? How do you overcome the challenges? How do you get your employees on board? And that's where NCI, I mean, they have a system. They've been through all of this before. They have contractors they guide through this. When you start connecting with NCI and start understanding airflow in the bigger picture, they can help you be successful and present that into your customers so that you can make some money, so you can keep the lights on, so you can keep the trucks running. And I suggest, if nothing else, David Richardson writes some amazing articles. And for me, the way he writes is easy for me to understand. I struggle reading technical stuff, but I have to. I make myself do it. But when David writes, I feel like he's just writing to me. Like he just wrote me a letter and say, hey, Ty, you need to be doing these things here. And here's why. And once I understand the why about it and how he words things so I can understand it, I started learning and implementing more and more stuff. And then I could take what he wrote and I could use that as a bridge to get to some of those other technical ideas. And like, if you've ever read ASHRAE manuals, you'll know what I'm talking about. But I can use what David's writing, and then I can understand some of the stuff that ASHRAE talks about. But if nothing else, just follow him on LinkedIn and see and I think every publication article he has articles in there, and I've been reading his stuff for years. So it's really exciting when I got to see him in person. I was trying to play it cool, like, oh, hey, David, how's it? But just to get to hang out with them and talk with them. And, it's amazing. It's awesome. And then when you talk with David, like he just says, like, oh, he's just a field guy. And I think that's important because we can all be there. We just have to take that step, that scary step of starting to try something new, starting to read stuff, starting to look at that bigger picture. And then, and you'll be surprised. Some of the things that you thought you were doing right, there's a better way. And it starts opening your mind. And it's that growth mindset.
Ty, I heard from Eugene first. I've heard from you. I've heard from other educators, and I experienced it myself. Many of us we don't know what we don't know until we're shown, right? Until we are exposed to that. So let's think about this. As contractors, we have this awesome opportunity to start learning through National Comfort Institute. Let's think about this as educators. Like I myself, I've not even had a chance to use the TrueFlow grid yet. I can only imagine some of the things that I could learn in the classes that I can implement into my own classroom. So David, as an instructor, and I'm looking to elevate the education in my classroom, I'm going to need some resources. I'm probably going to need some training, and I'm going to need some connections. So let's just talk about some of the ways that NCI is working to educate the entire industry, not just contractors, but an entire industry that is striving to be more efficient, to be better at the things that we're encountering and that we're teaching.
We're trying to get back to those principles that we talked about. And of course we do that through a couple different avenues. Now the writing, of course, we give that away. That's something that we do for the better good of the industry. I write for the ACHR News contracting
Mhm.
business. I don't get paid anything for that. That's just me
Oh,
donating
wow.
time so
Wonderful.
that they, there's no monetary gain there except trying to help others. Um, well, of course, also like appearances here that we're doing, just trying to spread the word and let guys see that there is a light at the end of the tunnel. That's not a freight train. And of course, we do have paid classes. That's how we paid for, what we do. It's we are a for profit company. I mean, we're all former contractors,
Absolutely.
and we're out there sharing our knowledge. But Marcus Aurelius, if you ever read his book Meditations, this is going back a long time. He said, "People who labor all their lives but have no purpose to direct every thought and impulse towards are wasting their time, even when they work hard." There's a lot of us that have been there. We've
Yeah.
worked hard, and it's like it's the old Dunkin' Donuts commercials. Time to make the donuts. You wonder, why am I hanging these ducts in this 150-degree attic? Why am I trying to service this unit? And so many times we focus on what we do and we forget to look at how we do it and why we do it. Simon Sinek wrote a book years ago called Start With Why. And he gets down to these core principles of our purpose, why we're doing what we're doing. And we try to elevate the industry through technical principles. A lot of people say, oh, you're a training company. Really, we're not. NCI is more of a culture change company than is anything. That was probably the biggest shift that it had in our family company. Was it changed our culture. It changed it to one of transparency, one of accountability. It changed our attitudes. It just so happened that they used the technical side to do that. So as we look at these measurements, there's a whole other level to it, at what we're trying to do. The craftsmanship, which is how you do stuff,
Mhm.
just gets glossed over. And what we're trying to do is make that visible through measurements, because no one can do what you do, how you do it, unless they do it the exact same way. And what you find is there's A+ installations, and guys know it, but they have no way to prove it. And there's guys who are doing F level installations, and they're like, I can hide. When you measure, you can't. You either have two choices. You can acknowledge it and do something about it, or you can ignore it and go back to doing what you're always doing. It's kind of like you talked earlier about the matrix. You're
Mhm.
taking either the red pill or the blue pill. Once you take the red, there's no going back.
Right.
You see things differently. And
Exactly.
that's how it is with measurements. But
Yeah.
it makes it fun, because when you get up, it's like, I know I can make a difference. There is nothing greater. One of the things we haven't talked about combustion, but I look so forward to every fall when I get text messages. Hey, just found this, saved these couples' life. That's why I do what I do. Getting that type of feedback. Ty, you talking about the articles, what type of an impact you've had. There's times when I'm like, what am I going to write about this month? I feel like I'm out of ideas. That type of a feedback. That's why we do. When students say, you've helped me help this customer, that's why we do. And as you guys do this, the struggles that you're going through, you may be struggling through something in a class right now, or struggling through something to teach your students. That's where your greatest lessons are. And if you look for them, if you look for the opportunity in those struggles, there's so many cool things that you can share.
And
Ty,
now
how
you
many?
have
Go ahead.
A-Team Adam with you too, and he was
Oh
a
my goodness.
contractor that was struggling, and he started learning these other things. And over the last 3 or 4 years that I've known him, he's just been a rock star reading this stuff, and he's just excited about it. He's excited about the trade, and now he's working with NCI. He's out doing the training, and
We
he
feel
talks
so
from the
blessed to
heart
have
because
him.
does it. He does it himself, and it's so great seeing people that's excited about the trade and love this trade. And also for instructors, the TEC, the Energy Conservatory, does a train the trainer class that helps get your hands on with this. And also sometimes they are able to provide some discounts for schools, but they show you not just their way. We went through and I went through the class, amazing class. You got Chris Hughes, Stephen Rogers, amazing, brilliant people. And they have you using the blower charts, and they have you actually find where the blower chart curve is, because sometimes that's difficult. They show you using the flow. They show you using all of the ways, which is great because you need to take all that back with you. So
Yep.
if you can, I don't know if they're when their next one's going to be, but that TEC train the trainer class was an amazing class. I came back on fire about it. I still get so excited about that class because it was so well done.
They're incredible with what they do. They're transparent with it. That's why we love those guys, because they are. I mean, they actually won our partner of the year at the summit this year. They are I mean, they're incredible at what they do. They're so transparent. And I got to brag on Adam for a second. You mentioned Adam.
Sure.
One of the things that Adam did, I presented with him at AHR.
Mhm.
We had everything that could go wrong with our audio visual. We had no audio visual. We had no room. We were locked out of our room. Adam had never presented publicly. And you talk about facing fears.
Wow. Yeah.
He presented, and Ty, you saw this. He presented to a group. There had to have been 150 people in this room.
And we're
He
talking not
presented them
just
with no audio
people, we're
visual.
talking high-end people. We're talking
Yes.
ASHRAE people, engineers, leaders of the industry were in this room. So it's not like you're just talking to students who don't know if you're saying something right or wrong. We're
Right.
talking like your most critical audience you could have.
Yep.
And he did it. He faced his fears and he did it. So if you're scared of doing this stuff, embrace it. That's what Adam did. He embraced his fear, and to see where he was to where he's at now, it's because he took that first step. That's where it all starts, is taking one step doing this stuff. The biggest obstacle that most people have, and this is easy to forget as we get comfortable with this, is installing that test port.
Properly.
People are so scared that they're going to drill into something.
I agree.
There's ways around that. There's specialized drill bits like what TEC makes that'll prevent you from drilling into a coil. There's diagrams that'll help to guide you on that. But these fears, there are obstacles that you guys can conquer if you believe in yourselves, and you're backed up with the right support staff. That's what ESCO and NCI are here for.
That's really what we're wanting to point out. You know, Ty and I have this conversation with educators all the time that are struggling to implement technology into the classroom. And they will also say in the conversation that they're struggling with removing technology from the classroom. And so if we have the heart-to-heart conversation of introducing technologies into the classroom that can be part of the educational experience, now we're getting somewhere. Now we're bringing technology in that could actually be part of your assessment, that you can actually use to better your measurements and improvements by following a process, stepping out of your comfort zone, going to the proper places for training, and moving beyond our comfort zone, because many of us have used tools that Ty is showing us right now, and they were perfectly usable and acceptable in their time, and they've all been replaced by something better, or at least more efficient. And we are getting up there, Ty. All right, we got a couple minutes left. Any questions, any comments from the audience? We're grateful to have so many people still hanging out with us here. Plenty of opportunity to ask Dave some questions. Dave, let's talk about ways that we can contact NCI. I shared that QR that'll take people to the website. I'll also have the web address to get to. And tell me a little bit about the NCI Summit, because I really wish I would have been able to get there this year. I was on the road traveling for A2L classes and was not able to participate, but I know you guys are just excelling with the amount of participants that are joining the NCI Summit.
It was a lot of fun. It has been and always will probably a grassroots movement.
Mm-hmm.
It's just a lot of like-minded professionals who follow the high-performance approach. When you believe in delivering comfort, health, safety, and efficient HVAC systems, improving it, gathering together under the same roof. I love this conference when I was a contractor. I still love it because of the authenticity. You have guys who are ultra successful who will share with you, here's where we failed.
Mm-hmm.
Here's where we messed up. Don't do this. And then you have guys that'll say, hey, I did this and had a lot of success with it. Maybe it'll help you too. And you see guys sharing. Those are so many gold nuggets. The presentations are great, but sometimes the side conversations, there's so many good things that come out of it. And just there's a buzz, there's an excitement. And that's, I think, one reason why we love the symposium so much that Brian Orr puts on, because it's such a similar feel. There's a grassroots movement to it, that you've got all these like-minded people getting together. And we do it in the fall. We're actually going to be the week of September 8th in 2025. We're going to be in Austin. So if any of you guys are in Austin and check it out, feel free to.
I'm showing up for this one.
Yeah. We're trying to improve the industry, guys. That's why we do what we do.
If you think of what we have now, we have a lot of private equity companies out there, and they have mastered selling the appliance, selling that box.
Yes.
And then you also have a lot of the cheap companies. It's a one-man guy, and he's putting in things, just slapping it in, and you can't compete with either end of those. So how you do compete is being better. And that comes with looking at the house as a system, doing these measurements, checking airflow. I hate it when I go to a house and I see that there's no ports in there at all. I know that nobody has ever checked airflow. And then I think they're about to have a professional, because I'm going to check these measurements and we're going to have a conversation with them. And the next thing you know, that customer doesn't want anybody else. When I moved to Miami, I had a guy that wanted to pay to fly me back to San Angelo to continue to do his maintenance because he finally found somebody that was doing the work correctly. And so the guy that bought my company, I had to have a very long conversation with him to make sure he did everything right. Because I was like, I need you to do things right, because I don't want to be flying back every 6 months to do his maintenance. But people look for that quality work. And there's some people that want things cheap. There's McDonald's. There's some people that want things good. There's Ruth Chris Steakhouse. And you just decide what you want to be. And you can be whatever you want to be, as big or small as you want to be. But when you take pride in your work, man, it's great. When you start looking at HVAC as the whole house, man, it's awesome. When you're solving problems that most people can't solve, it's exhilarating.
Ty, you brought up a really important point about, being able to get paid for what you do. And so many times there's going to be people that will go with the cheapest price. And many times in our industry, we'll complain about this. We'll say, their homeowners are only going to go with the cheapest price. And it's not necessarily that they're cheapskates. If they were, no one would have a Mercedes or a BMW or a Tesla in their parking lot. Here's where the problem lies. We are very poor communicators. We don't communicate the value that we bring. We don't communicate it through measurements, and we don't communicate it in ways that a customer can understand. So I would encourage you, if you caught yourself saying that, I have been guilty of that. I'm sure a lot of have, customers, they're just cheap. The blame goes right back on me. No, I'm a poor communicator. When customers don't understand what you're saying, they will go with what they do understand. And many times that's price.
Absolutely. I think about our programs the same way. When we look at a HVAC program and we're looking to elevate our program and to be that program that people want to go to, there's only one way to do that. You provide something that not everyone else provides.
Great point.
And David, we're going to have you back on for another conversation about CO, because that's another one that I'm very passionate about. And I've learned a lot of things from you on that as well. So, and also, the guy that throws the meters is brilliant.
Jim Davis.
Yeah.
He's the guy that wrote the original books.
Yes,
right.
He did all the original stuff. So we're going to have you come back, and we're going to have that conversation another day.
I see maybe a live demonstration class this winter, so maybe we can regroup on that conversation.
Nice.
All right. Well, we thank you all for joining us. It's been a wonderful hour of conversation about becoming a professional, a high-performance professional in this industry, resources that you have available to you. So we ask that you reach out to NCI and elevate your program and your company. David, Ty, thanks for joining us so much.
Thanks so much, you guys.
And we'll see you all next week on Did You Know? The ESCO HVAC Show.